Good morning. Hello. We're good.
Hello? I heard the class had like a 35% curve. Exactly. For now, which class is it for? 431. Oh, right. I'm so glad I don't understand. Got it. All right. I think I'm ready. All right, let's begin. So today we'll be going over the Nautilus cluster. Essentially, this is a way for UCSC students to be able to access powerful compute for your machine learning projects. So we'll start off by going over what is Kubernetes, and we'll go into a bit more detail into what Nautilus is. Additionally, we'll talk about Jupyter Hub, and which is another way of accessing Nautilus in addition to Kubernetes. We'll actually go ahead and actually set up Nautilus and Kubernetes on your machines. This is all optional if you want to try to follow along. And we'll also have a demo and walk through the different things you can do. So first off, what is Kubernetes? Kubernetes is essentially an open source way for creating different containers and connecting with larger systems and kind of a virtual machine style of container systems. Essentially, the best way of thinking about this is Kubernetes helps you create virtual machines from much larger systems. And so you can do a lot of complex things with them. For instance, you can create it such that it does a certain task and then automatically deletes the virtual machine. When it sets up the virtual machine, it does in a specific way. All sorts of things can be controlled with Kubernetes. And you can use this in multiple places other than just Nautilus. This is very important if you ever want to do anything with cloud computing. So if you want to use AWS, GCP, Microsoft Azure, all these will be using Kubernetes to be able to access their cloud resources. And so we're going to show some examples of how to do that with the Nautilus cluster. So when I say Nautilus cluster, what do I mean by that? Well, first off, a cluster is simply just a network of connected computers. In this case, the Nautilus cluster is a hyper-converged cluster. Not exactly sure what hyper-converged means, but just understand that the Nautilus cluster does contain a lot of individual computers or servers. These are also called nodes if I reference them in the future. And Nautilus is shared upon by, I think, the entire United States, but it is mainly held in the West Coast. As you see in this diagram on the right, we can see the different places that actually have access to the Nautilus cluster. In this case, this is just the US West region, but there's other places. If you see where it says the PRP partners in the bottom side, these are other places that might use the cluster. And so within this cluster, there are over 300 nodes, and some of which have really powerful GPUs, such as Quadro RTX 8000s, RTX A6000s, and there's some also that are not nearly as powerful. There's some with 3090s, 1080 Ti's, all sorts of things for whatever your computing needs. And some nodes do contain no GPUs. So if you don't need a heavy GPU workload, you can just use one that has only CPUs, but some have up to 16 GPUs in them. So some of them are really powerful and also in that case in high demand. And they're also using server grade CPUs. So that means they can have up to 128 cores in a single node. And same thing with the amount of memory, with some having, I think, around 2 terabytes of RAM, which is way more than one process should normally take up. So these are normally meant to split up, which we'll see in a bit. So the first part I want to show everyone is Jupyter Hub. Jupyter Hub is a way of connecting to the Nautilus cluster in a way that's much more friendly than Kubernetes. So if everyone's used Google Colab before, it's essentially the same way where you use the web to access certain resources, and you can play around with Jupyter notebooks, have access to the shell, all these different things. We'll go into a bit how to create a Nautilus account, but I'll show you a bit what the Jupyter Hub actually looks like. So if you follow those links below, you'll get to a page that looks like this. Well, technically first you'll have to log in, but Once you log in, you will also have to get access to JupyterHub. So if anyone does want to play around with JupyterHub afterwards, please let me know and I can help set that up for you. But once you do have all the accounts set up and have requested permission, you can see here that we can go ahead and request different amounts of GPUs, the CPU cores, RAM, etc. So if for instance, I wanted 1 GPU, you can request 1, or if I really want to, I could do like 4 GPUs, but for this case, I'm just gonna say 0. Same thing with CPU cores, how much RAM, and which GPU we want to in specific. So in my case, I don't care because we're not gonna be using any GPUs here. There's some other things you can change and mess around with. There's the image, which we'll talk about a bit later. And we can go ahead and create it. So it will try to look at all the different nodes that exist on the Nautilus server to match us up with one and create our own virtual machine that we can access through the web. So as we see, it has connected to our a particular node, and we'll be attaching what's called a persistent volume, which we'll get to later, but essentially allows us to keep our data saved through multiple shutdowns and turn-ons of the different nodes. So again, I'll cover all this later. This is just a quick example as what you could do without having to play around with the terminal. So for later on, we will be using the terminal. So I hope everyone is somewhat familiar with it, because that is what we'll be playing around with. But once this loads, you can see kind of what it looks like. And it should be very familiar to you if you have used Google Colab. So as we see here, I have here all the different files I've set up on my account. A bunch of different things from different projects I've had, some random files. As we hear, this is one of my homework assignments that I had to run. And so if you want, you can just edit the same thing with Google Colab. It literally runs exactly the same way. If you want, you can also create a terminal. As you see here, terminal, you can do regular terminal things, right? If you want to install things, you can use pip install, sudo install. You have complete access to the shell with administrative access. You can do whatever you want. And this is a very easy access to use Nautilus if you don't want to have to go through the hassle of using Kubernetes, which again, we'll get to in a sec. So I'm going to go log off of this and we'll begin the Kubernetes journey together. So setting up Kubernetes. So before I get into this, I'm going to need everyone to install Kubernetes on their computers if you want to go around with me. You don't have to follow along, but if you do, you will have to install Kubernetes onto it. You'll be installing the kubectl command line interface, which is essentially just a command that you can use on your terminal to help run Kubernetes. So the link to the slides are posted on the Discord. So if you do need to find these links for if you're on Linux or Windows, you can go find the slides there. So if you're on Mac, very easy, reinstall kubectl. Or if you want to go a different way around, you can go to that link and it'll give you more instructions. Linux, if you want, you can go to that link, or you could just copy those two commands, the curl command and then the sudo install based on that binary file that you just downloaded. And if you're on Windows, good luck. In which case you should probably just use a virtual machine or some other terminal system that you have set up. While you guys are doing that, I'm going to keep explaining. Can I get a raise of hands of who actually does want to follow along? Because that helps me identify how fast I should go. All right, cool. So while you're setting that up, I'll keep talking about connecting with Nautilus. So once you guys have finished installing Kubernetes, or while it's downloading, you can follow these next couple steps. So in order to actually get set up with Nautilus, you have to create an account, which will just be through your UCSC account. So just follow the link here, which will get you the Nautilus homepage. On the top right, there'll be there should be a login. Let me see if I can get to that and show you guys. Oops. So here's Nautilus. This is the homepage. Let me log out. All right, so your guys' screen should look something similar to this if you get to the Nautilus page. Is anyone at this stage, or are you guys still installing Kubernetes? All right, cool. If you're at this page, go ahead and go to login. It should either send you something like this or some other login method, in which case you might have to click something that says create account. I don't know if you guys found a create an account button in the previous page or not. I don't remember exactly what it looks like, but it should be a very simple create account. Use your UCSC email. It should eventually bring you to a page that just logs you in via this. Once you're logged in, however, you should get to a page that looks something like this. Can I get a raise of hands once you have completed this step, or shout out something if you need help? All right, once you've created your account, they should say you are a guest and that you are not connected to any namespaces. So in order to be able to use it, you have to be connected to a namespace. A namespace is similar to being part of a lab. This just helps them identify which group you're part of when connecting to the Nautilus cluster. So to join it, I'm going to need everyone's email addresses. So if you're not already part of a namespace, go ahead and send your email to the Discord and I'll add you guys to the namespace. Yeah, let me make a thread on Discord. Yes, you can join multiple. Not for no, if you're already in it from previous things, you don't need to do anything. The same one is the yeah, it is. All right, so if you is anyone still trying to send it? Dylan. All right. Is anyone else following along or like wanting to follow along? All right, cool. Should just be Dylan. So I will be adding everyone to the Cohen Lab namespace. I know, great name. I couldn't come up with anything better at the time. But oh, please select these. So now when you go to should be the namespace manager, you should be able to see the Cohen Lab namespace show up, I think. I'm not 100% sure. But tell me if you guys can I get a thumbs up if you're able to see the Cohen Lab under the namespace list. Dylan, you're good? Perfect. All right, so the next step is once you finish downloading Kubernetes, you're going to also need to download this config file. This essentially tells Kubernetes, hey, I want to connect with this specific system. In this case, when I say this, I'm talking about the Nautilus computer cluster system. So once you've downloaded that, we're going to have to move it. So I'm assuming you download it into your downloads folder. You're going to want to move it to a folder in your home directory. Let me show you what it would look like. So once you're in your home directory, you want to save it into the /kube folder. Before you do that, the way you are able to, you have to first create the kube folder. So it's make directory. Let me zoom in for a sec. And then the .kube with a K. So you want to make that in your home directory. Once you've done that, then you can move the file, move the config file from your downloads into that .kube folder. So, Dylan, is everyone able to get that? And I think everyone has to do that. I don't know. Have you done it already? Yeah, you have. Okay, perfect. So let me know if you have any problems with that. And so it should look like, oops, ls. So your kube folder should look something around this. It might not have cache, but it should just have the config file, which doesn't have anything at the end of it. Can I get a thumbs up once you guys have set that up? Perfect. All right, let's go into actually playing around with or learning about Kubernetes. Actually, I should take that back. Sorry. We have to verify that you got everything set up. So can everyone type the kubectl get pods -n Cohen lab command? You should be able to just copy it from the slides here. Let me make sure everything is working. That's perfect. So that means you are able to connect because right now there are no resources created in the Cohen Lab namespace, which will change very shortly. So just so that we don't have to type -n Cohen Lab in the future, let's set our default namespace to that Cohen Lab using the second command here. While you guys all do that, I'll introduce everyone some important vocab that I'll be using a lot in the future. So As you've been noticing, I've been using the word node a lot. Node essentially is a physical computer. So think of literally the server rack that contains the CPU, the GPU, is that physical computer. On the other hand, everything else I'll list are all the virtualized portions of the node. So the pod, which is the most essential piece of Kubernetes, you can think of it as like a synonym to a virtual machine, where everything that we create will be in the form of a pod. So think of a small space within the node will be considered a pod. A deployment is a way of generating these pods with a bit more control to it. So for instance, you can create a deployment that will create multiple pods, or will say, hey, at this point, make sure to delete the pod. There's a bunch of different controls that deployments allow you to have over the creation or deployment of such pods. Again, we'll go into all of these further. Next is a job. Job is what I suggest everyone to use when it comes to actually running your machine learning models. Again, we'll go into this a bit later, but essentially creates a job for a single purpose. So you give it what commands you want to run. It runs those, and then automatically cleans up the pod and makes everything disappear. It kind of erases everything and resets it all. Next piece is the persistent volume claim. A persistent volume claim is a way of getting persistent storage. We'll talk about what that means later, but it mainly allows you to retain data between the deletion and the recreation of pods. And then I have service here. I'm not going to really go into service, but again, it helps you set up pods in a specific way. So for instance, if you're creating a web server, you might want to use a service rather than a deployment or any of the other pieces. So let's get on to the demo. So pods, this is kind of the main piece of Kubernetes that I talked about. And when you create them on the Nautilus cluster using Kubernetes, they will only have about a 6-hour lifespan. So you typically would not be using pods for any long running models. You might just use it to test, hey, let me just make sure that this actually runs using this given environment. Maybe I need to install something. Just use a pod for testing, something that you won't need long term. So let's go ahead and create the pod. The way we create anything in Kubernetes is through YAML files. YAML files are these configuration files. And the way that we're actually I'm going to be sharing all these files with you. If you want, you could just type it manually, or you can have all the files download onto your computer from a OneDrive link that I've sent in Discord. So if you can see on Discord, I sent everyone all the files that you'll be needing to download. So for that, you should, after you log in with your UCSC account, you should get something that looks somewhat like this. This should have all the files you need. Go ahead and download every single one of these except for the PowerPoint. You'll need all the YAML files for all the tests. Actually, everything except for the PowerPoint and the bottom one that says the XI machine test. You don't need that. Just put your UCSC email in there and it will automatically bring you to the UCSC login page. So while you guys are downloading all of that, I'll keep going on the presentation. So this is what a very simple, the most as basic as you can really get of a form of a YAML file. This contains multiple different pieces. As you can see in that first line where it says the API version, again, this is the version of Kubernetes that we'll be using. In this case, it's the version 1. This might be different for if you're creating a pod, a deployment, or a job, which we'll see later. Then we say what kind of Kubernetes abstraction are we creating? In this case, we are creating a pod. So as you see here, our kind is a pod. And then we have some metadata. There's other things that go in here, but mainly it is used for putting the name of your abstract system. So in this case, I have test pod. For everyone else, please make sure once you download the files that you edit the name, because what will end up happening if we all have the same name, it'll say, sorry, we can't create this because that name already exists. So make sure you go change the name. So change it to test pod and then your name. So for instance, test pod Cohen. Additionally, it says, what exactly specifications should we give this pod that we want to create? And so as you see here, you have the image. So the image is kind of like the OS or all the things that the environment that we want our pod to be set up with. As we see here, it's the basic CentOS image that we want to set it up with. It has a little bit of things installed onto it, but it's pretty small and it is missing some things, but this is just basic. So we don't really need anything too big. The next part is our limits and requests. Limits and requests essentially say this is how much memory, CPU, or GPU we want to request for our pod. So in this case, I'm only going to be requesting 100 megabytes of memory and 100 M of CPU. 100 M represents 100 milli CPUs. What exactly is a milli CPU? That's a great question. I'm not 100% sure how you can have a tenth of a CPU, but that's the cool thing about Kubernetes. It's able to virtualize it such that you can have these milli CPUs. If you just want one CPU, you could just put the number 1. But in this case, it's very small. We don't really want to request too much here just because this is a quick test. And then we have the command we want to run. We just want to run a quick shell script that says, hey, I'm a new pod, and then we want to sleep forever. And by sleeping forever, it just stays open until we decide to shut it down. Yes?
Where do we place the YAML file? Do we also place that in Nautilus?
No, that doesn't matter where you place it as long as you have access to it when we actually run terminal commands. So talking about using terminal commands, now it is time to actually run everything. So if we go back to our terminal, can everyone see my terminal? Is this too small or do I need to make it bigger? It's good. Perfect. So usually I'll start off by seeing what pods already exist in our namespace. So currently, as we saw by just the previous command I typed, we type kubectl get pod, and it'll show, hey, look, there are no pods in this namespace. So let's go ahead and create one. So as we saw in the slides, I've already created that test pod YAML file that automatically generates their pod. And so to be able to create it based on that YAML file, we want to type kubectl create -f, which indicates that we're creating it based off of a file. And then we give it the testpod.yaml file. So I'm already in that correct directory. You might have to cd into the correct directory, but you running this kubectl create -f testpod.yaml will create the pod. And I see someone's created it without changing the name. Good job. So if we could see, I'm not going to go create a new one. I'm just going to use whatever pod someone already created. As we see, someone has already created a pod called test pod.
Oh, my bad.
Don't worry about it. I'm just going to, we'll end it later. I'm just going to use yours as an example. All right. So as we can see, it is currently running and we can see different pieces of information about it. So if we want, we can actually get Kubernetes to describe more details about that pod. So we could type kubectl describe, and then we want to make sure we're describing a pod. So we just say describe pod. And then which pod we want to describe? Well, we want to describe the test pod. So we copy the name, paste that, and enter. And this will show us all the different details about this pod. If you're not really following along at the same pace, all these commands are in the slides. So you can check the slides if you miss a command. So in the actual file itself, so the YAML file, as we see here, there's the metadata, which contains the name that you want to give it. So you change this to test pod Kevin, right?
Okay. I thought you were supposed to change the file name.
No, the file name, no, that's something completely different. But as you can see within the describing pod, it gives us all the different information that we need. It says, hey, look, this is the name, this is the namespace it's in, when did it start, some random stuff about the IP, the current status, all sorts of things that might be important for debugging the pod, which, let's be honest, you'll probably have issues with later on. Another thing that we can get information about it is the logs of the pod. To get the logs, we could type kubectl logs and then the name of the pod, in which case we're talking about test pod. So we could type kubectl logs and then see, hey, look, it printed out I'm a new pod, which makes sense because when we did create that YAML file, we made sure to echo out I'm a new pod. So if you look again at that YAML, we see in the commands, echo I'm a new pod, which printed out I'm a new pod, which is exactly what we want to do. Yes.
What does the sleep infinity do?
Sleep infinity just tells it to remain dormant until we destroy it. So otherwise, if we don't have sleep infinity, it might automatically close up.
Yeah, I think technically you're not supposed to use sleep commands in Kubernetes.
You are supposed to use sleep infinity if you're using a pod deployment. But if you're using a job, which is very different, I have a whole other thing about that, you don't want sleep infinity. kubectl create -f and then the name of the file. All these commands that I'm running are all right here. So if you ever want to check it out, even after this presentation, then you can see everything here.
And
Should have
to
more.
delete a pod, you do vector delete in the pod name.
Yep, we'll get to that. Please don't delete it. We're not done with the demo. So I'm going to make sure that you didn't delete it by checking what pods exist. And we could see that we still have the test pod. It's been running for 3 minutes. So, however, let's say we did actually want to run some commands in it. Well, we would need to SSH or exec into it. This is a more complex command. So just go look at the slides if you don't have this, you're not caught up. So kubectl exec, which tells us that we want to execute onto a pod. We want to use -it. What that means, I don't know. And then the name of the pod that we want to exec on. So I'm going to go exec on to the test pod. And then I want to type /bin/bash. Why do we need all those? I don't know, but that's the command that we're going to be running. This should SSH us onto that pod. So as we see here, we're no longer on my laptop, which is my CAG14. We're now on our test pod. So we can do whatever we want. This is running CentOS. So whatever command CentOS has, we can run it here. So if we want, we can play around. We could cd into our home directory. Let's go create a file. I don't know. Let's do hello world touch, or let's echo hello world. And let's put that into test.txt. And we could see, hey, look, our test.txt file exists. And we can see that it does contain things. You can mess around with this on your own, but it should run like a normal OS with 100 megabytes of memory, which really isn't much. Yeah.
How do we edit text files? Because I don't think a text editor is installed.
So you can use Vim, you can use Nano. However, those are probably not installed. So you would have to install it. Which one?
VI.
These, okay. Well, anyways, this is really limited. Yes. If it's set up on CentOS, sure. But the thing is, you're probably not going to be wanting to use CentOS as your image. We'll go into more about images later. So let's go ahead and log out of our pod because we're done playing with it for now. And we could do so by using Control-D. On Mac, it's either Control-D or Command-D, or it might just be typing exit. But you can exit and you should be back onto your regular computer. So now we can see that our pod still exists, and now we can go ahead and delete it. So anytime we create a pod, when we're done using it, and this goes for every resource we create, we want to delete it if we're not using it. Because if we reserve, let's say 6 CPU cores with 1 GPU, if we don't ever release it, that means no one else can use it. So it's kind of like hogging the resources, which you don't want to do. And I also don't want to get in trouble for people hogging it. So let's go ahead and delete it. So the way we can delete it is by typing kubectl delete. And then we want to say we're deleting a pod. So we say delete pod and then the name of the pod. So you see here, kubectl delete pod test pod. And this should delete. Sometimes it takes a bit. Don't worry about it. Also, never force delete pods. You might have an issue later on where you want to force delete. Do not force delete it. That creates issues on the server.
I'm still in the pod. How's it working?
It's not. I don't know. Just try exiting out. Anyway, so while this is happening, let's move on to the next part, deployments. So deployments. Deployments I actually suggest you guys not to use because I've noticed people forget to close their deployments and this can have lasting issues. But deployments are more controllable ways of creating pods. They give you a bit more freedom in what you could do with it. And one of the nice things is when you create a pod via a deployment, it lasts for 2 weeks. Technically, it can last for longer if you request an extension, but it can last a lot longer than the 6 hours or so from a single pod. So when you create a deployment, it will automatically create a pod. And one of the cool things about deployments is that if that pod, for whatever reason, crashes, let's say your code gets a seg fault and kills the OS, I don't know, it will automatically restart the pod such that it is already running with whatever you needed set up. And so that is one case you would use deployments over a pod. So let's go ahead and look at what the YAML file for a deployment looks like. This, as we can see, is similar, but a bit more complex than the simple pod YAML file. So this is the test.dep.yaml file that you should have already downloaded, but we can just view it here. So the API version we'll be using here is apps/v1. I haven't really played around with changing these API versions, These are just kind of some sample ones you can play around with. As you see here, the kind is a deployment rather than a pod. You have the metadata. There's a bit more to it, but we can still see that the main part is that we have the different specifications, which have our limits and requests. As we see here, though, our limits and requests are actually different. And that's because limits is essentially saying, hey, this is the amount of resources that I would like, but I am okay with the minimum being the request. I'm okay with 100 megabytes of memory, but if possible, I would like 500 megabytes. And same thing with the CPUs. I would like half a CPU core, which is 500 milli CPUs, but I'm okay with 50 milli CPUs, which is tiny. Yes.
Okay, if we have to rename this, do we have to rename the K8 app as well?
I'm honest, I'm not 100% sure about how the K8's apps work, but I'm pretty sure you only need to do the name of the deployment. So change it from test step to test step your name.
I mean, if it doesn't work, try to use it as well.
Yeah, the K8's app, I'm pretty sure that's only for matching so that the deployment knows which specific specification you're talking about. Because as you see here, we're using the template, which is the K8's app test deployment. That's this whole thing. You don't have to worry about this. If you are trying to create a YAML file yourself, I suggest to start off with an already created YAML file and then edit that rather than typing up on your own. Because so many times you realize you type something wrong. There's a small typo. Oh, you use indent instead of a space. It's annoying. But this should set up a deployment. So let's go ahead and do that. So let's go kubectl create -f, and then we want to create our test deployment, which should be testdep.yaml. So it says it's been created, so we could see what deployments actually exist on the current namespace. So I could do, instead of kubectl get pod, we want to do kubectl get deployments. And this should show all the deployments that exist. So as we see here, we have the test deployment that I created, one that Ant created, one that Kevin created as well. As we can see, currently, at least right when I type that command, the one that Ant created and the one that Kevin created have already set up and they're available, whereas the one I've set up might not be available yet. So let's go check it out. So we can type kubectl get pods because these deployments do indeed create pods. Again, as we see, it was able to create all these different pods using that deployment. So as we see, we have our test deployment name, and then we have this random assortment of numbers and letters. This is the hash. So essentially, anytime you create a deployment, it will automatically create the pods with some hash. So in case it needs to create something later, it is able to differentiate them. So let's go ahead and SSH or exec onto this new pod. So it's the exact same commands we used before, kubectl exec-it, and then the pod name. And then we want to do space -- and then /bin/bash. And we should be able to SSH onto the pod created by the deployment. So let's go create that hello world file again. So let's see, let me cd here, and we'll do echo hello world into test.txt. And I didn't do that correctly. So we can see that the test.txt exists and contains the contents of hello world. So if, for instance, we deleted this pod, we could see that the pod will automatically be recreated because we set in our deployment for it to recreate. So if we type kubectl get pods, we can see all our pods are currently existing. And so let's see what happens if we delete the pod created by our deployment. So kubectl delete pod and then the pod name. It says delete the pod, and then we'll check to see what happens when we do kubectl get pods. Sometimes it gets stuck like this for a minute. Sometimes this happens instantly. While it's deleting, let's go check it out on a different screen. So let's type kubectl get pods. And we should be able to see that, hey, it is currently terminating the old one. So this is the old deployment or pod that was created. It's currently terminating that one and already immediately recreated a new pod. So this kind of shows that, hey, with the deployment, if a pod goes down, it will automatically restart and create a new one. Yes. Oh, yes. Let me go set that up then. Right, you should be added. When do you have, what step are you on? All right, make sure when you place the config in the .cube folder, you have to create the .cube folder beforehand, because I forgot to put that on the slides, I think. All right, so let's go ahead and exec onto that new pod that was just created by the deployment. So we do kubectl again, exec -it, and then the name of our pod. So this pod will have a new name because, again, that random hash is different from before. ///bin/bash. And one of the interesting things is that we could see that our hello.txt or our test.txt file that contained hello world is no longer here. It no longer persists any of the previous memory. So everything that we altered or messed around with in the previous pod that we deleted is gone and no longer is here. So that's kind of a problem because if you're running an experiment, you do kind of want to save your data. So we're going to next about how we can save our data using persistent volume claims. So before we go to the next step, remember every time you create something that we delete it once we are done using it. So to delete a deployment, because as we saw, deleting the pod just makes it recreate. We want to actually delete the deployment itself rather than the pod. So we can do kubectl delete deployment, and then name of the deployment. In my case, is test depth. And that should delete the deployment. In that case, it was instant. Why it's instant, why it's not instant sometimes, I don't know. So let's go into the next step. So the next thing is the persistent volume claim. This is a mechanism for attaching pods or different other resources to physical storage. So this way, when you create a pod, you could say, hey, I want to attach to this storage that will never get deleted. And so maybe you want to actually connect this storage to two different pods so that they can share memory. This is a easy way of doing so using a PVC or persistent volume claim. So this is what the YAML looks like for a PVC. Very simple and self-explanatory. Again, the kind is the persistent volume claim. We are using the Rook CephFS storage class. What exactly that is, I'm not too sure, but a lot of people brag that this was actually created here in Santa Cruz. The CephFS storage system was created here. So woo, let's go Storage Research Center. One other piece that's important is the access mode. So this could be read, write many. It could be read, write single. There's other different ways you can have it. Technically, you can have it read only, but these are the different ways you can have for your persistent volume. In our case, we want to be read, write many because we want multiple pods to be able to access this at the same time. Additionally, this is also where we have how much we want to request. As we see here, I'm requesting 16 gigabytes of storage, which is a very, very small amount, especially when you can see like how large each of those nodes are, containing probably more than 64 terabytes each, something crazy like that. But you're able to set that with whoever you like. For this, we'll just be using small amounts. So this again is saved in our test pvc0.yaml file. And when we create it, make sure you do change the name here. So let's go. I just must have clicked something weird. Let's go and create our PVC file. So create -f, and we want to get the test pvc0.yaml. That creates that. So now we can see what PVCs exist. So kubectl get PVC will show us all the PVCs that currently exist. So see here, I have a bird volume that I created 42 days ago, and test volume 0 ant, and they have 16 gigabytes read, write many running with Rook CephFS. So let's see what happened. Let's see how to actually connect a pod to these PVCs because we want to actually save our data. So we want to create now two pods. They're both mounting our PVC file. So these are going to be very similar pods to what we created at the very beginning. We'll have test pod 0 and test pod 1, where test pod 0 is running CentOS 7, which is slightly different image. You don't really have to use that version of CentOS. But the main difference is that we want to use a volume. So in this case here, we're saying we want to use the volume and we want to connect to the persistent volume claim test volume 0. So if you change your name of your persistent volume claim, this is where you would want to change it to test vol 0 and then your name. just so that it makes it so that your pods are going to be attached to your specific PVC. So as you see, we're then calling this PVC example volume. So anytime we see example volume later on, that means we are referring to the test vol 0 PVC. So then when we do create our pod, we want to mount this volume under the file path /PVC volume. So in our root directory, there should be a folder called PVC volume that will be our PVC volume. So let's go create both of these pods. So again, if you are testing yourself, make sure to change both the name of the PVC and also the claim of your PVC as well. So let's kubectl create -f. What was it called? Test PVC pod 0.yaml, and we're gonna do the same thing, but for test pod 1. So we've created 2 identical pods, both attached to the PVC that we created earlier. So you can see that it exists. Kubectl get pods. Say, hey, look, we have our test pod 0 and our test pod 1, and it's currently creating. So we could see its current status by describing those pods. Describe pod and then test pod 0. So you can see sometimes it gets stuck somewhere, sometimes didn't. Right now, it says that it has started. So if you go back, we should be able to see that it is currently running. So you see now that we're all running, sometimes it takes a second to get started. So let's go ahead and exec onto our newly created pods. So kubectl exec -it, and then the name of the pod. So test pod. We'll start off by going to test pod 0 /bin/bash. I forgot the -- and it didn't like that, so it's deprecated, but it's fine. Yes. Did you modify anything? Are you sure? Do not copy paste it. So on Discord, I sent a link to a OneDrive folder. So download all the files except for the PowerPoint and then the XAI test machine.yaml file. Copy all those into your computer. That way we don't have to worry about any of those weird indentation stuff. All right. So now that we're on our test pod, let's go ahead and see that our PVC volume mount exists. So you see in our root directory, our PVC volume actually exists. So let's go cd into it. And we can see that, yes, it is empty. We didn't actually store anything. We just created an empty volume. So let's go add something here. So again, I'll do the good old hello world. You can add whatever the heck you want there, but I'm going basic. I can type, and we'll put it into the test.txt folder. Yes.
If you want to install packages on a pod, how do we do that?
Same way you install it on your computer. You literally type, let's say, sudo apt get install whatever.
That did not.
That's because we're running CentOS, and CentOS doesn't have the apt get. What? I don't remember, but it doesn't have. You have to use yum install. I suggest you don't use CentOS when you create your pods, which we'll get into later. But we'll just, if you want to play with it a little bit later, we'll go into more descriptive. Yeah, I'll go past it. There's nothing I can do. This one always takes forever. All right. So now let's see that our file is created, and let's see what happens if we actually. Oops, I just deleted my terminal. Give me a sec. All right, cool. We're back. So now we could see that we just added something to our PVC. So let's go ahead and delete the pod that we just created. So we want to make sure delete kubectl, delete pod, and then I'm going to be deleting the test pod 0. So now the pod is deleted. So if this data wasn't stored in a persistent storage, that data should just be gone. But luckily, we did save our data onto that persistent volume claim. So that's where we saved it into that specific folder. So hypothetically, when we open up our test pod 1 and exec into it, we can see that it still exists. if you want to do that, go ahead. We are running low on time, so I will skip that step. You should take my word for it, or you can test on your own. But make sure that you delete your pods afterwards. So looks like this one's taken a bit to delete, but let me go ahead and delete test pod 1 as well. And then I will also delete the PVC while I'm at it. Kubectl will get PVC. Kubectl delete PVC, and I want to delete test volume 0. So make sure you delete everything that you have created. So if you want to keep playing around with it, you can, but I'm just going on to the next thing. All right, back to the slides. And if you ever need to go look at these commands again, everything that I've typed should all be here. So you don't have to worry about anything. All right, next, jobs. Jobs, I highly suggest everyone use jobs if you are trying to run a large model or really trying to run anything that you've ensured works correct. So the main thing about jobs is jobs are cool. They can run forever, which is also why you should never use the sleep infinity command. Because if you do so, it will never end. Yes.
Can't you use Cgate or Control C?
Okay, sure, yes, there's all these edge cases. Do not use sleep infinity. That is a rule on Nautilus. You can get
that.
Yes, you will get in trouble if you do use
Not allowed to.
sleep infinity. Yeah. Anyways, so one of the interesting things about jobs is in the YAML file, you tell it exactly what you want to run, and it will run it. And once it finishes completing, it will automatically close up everything. It will delete the pod, and it will also, in the case it fails or something breaks, it will try to restart and set it up again. So let's go ahead and play around with a simple job. So this is a two-piece thing. So this is what the job looks like, or the YAML file. In this case, we're using the API version batch v1. The kind is a job. Again, please change the name of the job. We will also be, again, using a PVC, so you might need to change the name of the PVC, which we'll create in the next slide. And as we see here, we are no longer using the discussing CentOS. I'm sorry for those CentOS lovers. We are using a different image. In this case, we are using the image that is in the GitLab registry of Nautilus. So this is basically the latest version of the Jupyter Stack image. So this is going to be running on the typical, my brain's going, what's the basic Linux?
What do you mean basically?
The most common Linux. Ubuntu, thank you. It's running Ubuntu. It has Python installed. I think it has Vim installed. It has PyTorch set up. Everything is set up on this one. Unless you need some weird special OSGeo pip install thing, it will already have it set up. So this is much easier. And we'll also be requesting a bit more CPU and memory. This already is more CPU and more memory than we actually do need. So be aware of how much you're requesting. Most things do not need nearly as much as even this. Yes.
With the other like pods and the pods and stuff, can we just change that image from CentOS to this link and it'll run with that?
Yeah. And there's tons of different images. How you look them up? That's a great question. We could talk about that afterwards. So as we see here, the main piece is the commands, because in a job, it will run the commands and then automatically stop and close up. So we say, hey, we're running a shell command. -c just says this is the command we want to run. And as we see, we are going to first CD into our persistent volume. So this is where we have the persistent volume mounted to, and then run this file called the decision tree.py. We'll get into that in the next page. So let's go actually create our PVC and pod situation, because we do want to be able to upload our files to our PVC. So we'll go into this in a sec. We've already seen these examples, but this will be on the two different files. This is, I don't remember exactly which commands it is, but these are a pod and a PVC. And we also have our decision tree script right here. This is our decision tree.py script, which essentially just imports scikit-learn, creates a decision tree based on the iris dataset. I'm sure many of you guys have seen this iris dataset before. Creates an image, and then we'll save it as tree.png. And then that will be saved onto a persistent storage, which then we can then pull and save locally. So this is how we'd run something. We'd tell it to, hey, this is this script that we want to run it. It will create the file, output file, or whatever you need, and you can then download it afterwards. So let's go into the commands we need to run. So first thing we want to do is we want to create the the PVC. So make sure again you use the correct name for this PVC. I'm using the regular just test PVC. So we'll be doing test PVC1.yaml. I forgot the -f. Oops. Someone's already created it. Don't worry about that. We'll just share that together. It doesn't matter. All right. So next we want to create the pod. So create pod, and then this is test. I don't know what I called it. Test job pod. Test job pod. I know, amazing naming scheme. And it already exists. I'm not going to worry about that. No, that's fine. So now we want to copy a file from our local machine to the machine or to our PVC. To do so, we want to use the kubectl cp command. So we want to copy. So we do kubectl cp, and what file are we doing? We want to copy the decision tree file, so decisiontree.py, onto the test pod 1 pod. So to do so, we say we want to give it the test pod 1 and then colon, and then we want to say where we want to save it to on that pod specifically. So we want to save it onto our PVC volume folder. So / PVC volume. Let me make sure I typed everything correctly. Yes. So this should copy the decisiontree.py into the PVC volume within our test pod. If you want, you could double check this by exec into that pod. We're just going to assume that worked. So let's go ahead and create our job. So now our job is going to mount to the PVC, and that PVC should already contain that decisiontree.py folder, or that decisiontree.py file. And so let's go and create that job. So kubectl create test job.yaml, I think. Yeah, test job.yaml. Again, make sure you change the name of it, and we should be able to run it. And we see that it has been created. So we could do kubectl get jobs. It should say it exists and it is not completed, because it does take a little bit of time to set everything up. So let me see if it's completed already. Kubectl get pods. So we can look at the pods that we've been setting up. So as you hear, when we look at the job, it says it is completed. That means it ran all the way until it had no more commands to run, and it is completely done, in which case it should have created that tree.png file. Again, if you want to go and SSH into that pod to ensure that it actually was created, you can. You can just SSH into our test pods again. And now, how do we actually copy a file from a PVC or from a pod onto our local machine? So to do so, let me just make sure I don't already have the tree PNG already set up. I don't see tree.png. Perfect. So to do so, we could type kubectl cp, and then we want to say it's coming from the test pod. So test pod 1 colon, and then the file that the folder it's in is PVC volume. And the file that we want is the tree.png file. And then we want to save it to our current directory, and we want to name it as tree.png. You can again name it whatever you want, save it to wherever you want, but this should just copy the file over. And so as we see, it did create our tree.png. And so if we want, we can actually go look at it. I saved it to some random folder. And it should be here. And cool, we have our nice little decision tree. I can full screen it. We have our decision tree that we were able to make using that job. And so because it was a job, it automatically closed up the pod. So the pod's no longer running and everything is neat and organized. So now we just have to make sure that we actually do delete the job, because the job still exists, even though nothing is really running. Kubectl get job. See, so it says it's 1 out of 1 completions. That means it did complete. You can see how long it took to complete. So it took mine 17 seconds to actually run the entire decision tree command. This probably includes also the setting up of the actual pod itself. So probably took a little bit less than 17 seconds, but we can go ahead and delete the job. So we do that by kubectl delete job and then test job. And so that should have deleted. So we can see, we can double check that it did get deleted. All right, nice. So that is all of the demo part. There's still more to the presentation, but this is all the demo thing. So make sure if you're not still using the pods and deployments that we just created, that you delete them afterwards. So make sure to also delete the PVC that we just created. So delete PVC, was it test PVC 0? I don't remember exactly what it's called. Nope. It's just called test PVC. Oh, okay. My inconsistent naming scheme. My amazing listening skills. Perfect. So let's delete that. I also have a pod that I need to delete. So let me go delete that real quick. Go back to look at pods. And then let me go delete the pod, which is test pod 1.
Good job, this is automatic close the pod.
So this is the pod that we created now. So don't forget, we created a pod manually so that we can actually upload our data to the PVC. And then also one that was created automatically by the job. Yes. That is beyond my scope of knowledge, but if you would love to be a DevOps master, go ahead and. There's tons of ways you can probably automate it. I'm not going to worry about that for now. But the main way is if you do have this really complex PyTorch file that you want to run, you want to just essentially you create the pod, attach it to a PVC, upload the Python file, and then create a job, which also attaches that same PVC. Make sure you have the commands that actually runs that Python file, and it should run it, outputs whatever you need, and then you can collect that data again, same way that we did here. So that's the basic way you can use all of that. But as we showed, those were only for very small examples using just the CPU and very little memory. If we want to actually use a GPU, it's a bit more complex, especially since they are in high demand. So as we see, GPUs are very often requested. So some of them are going to be better than others. So if you could see the tiny script here, these are all the different GPUs that Nautilus has available, going from top down from like worst to best. So it has 1070s, 1080s, and 4000s. All the way down to RTX 8000s and RTX 6000s. So if you want to check to see which GPUs and nodes actually exist currently, you go to the resources link here, which should look something like this. And this will show all the different nodes that are currently in use, how much is free and available. And so the way we can actually check which ones are accessible to us is we want to say, hey, let's say we want a machine with at least one GPU. So we say, hey, we want to make sure that you want one that has at least one GPU, so greater than or equal to one GPU. So this will filter everything so it's one GPU. And we can see here all the different GPU types. For some reason, sometimes you might see this really, really small. You just have to expand it so you actually see everything. In some cases, you can access nodes with taints, but for the most part, you can only access nodes without taints. We want to make sure that this section is blank. Taints essentially is a way of giving access to only specific people. So we want to make sure this is blank. In addition to that, we also want to make sure that we are accessing something from the US West region. I'm pretty sure we don't have access to the EU region or the US East. You could try it on your own time, but just to be safe, I know for sure that US West works. So we could type US West here, and it filters to all the available US West available nodes. So you might also want to make sure that it has at least however many CPUs free that you need, and you could scroll down to see all the ones that exist. So as we can see, there are tons of ones that are available, even some that are really strong like this, the A6000s. The ones in yellow are the ones which are in high demand, and the ones in red are the ones which there are no ones in red that you can't access for whatever reason. So maybe it's closed off for testing or there's no resources available. So this is a way to see what is actually available to you. Because if you request something that isn't available, it will just loop for whatever, however long until it decides to give up and not connect to a node. So how do we go about requesting a specific GPU? So let's say we want to make sure that we get an A6000. Well, we can use this here. So this is something very similar to what we saw before. We're just creating a simple pod. You could change this to a deployment or a job. Again, please don't use deployments unless you're going to be very, very good at deleting things. If you forget to delete the deployment, it will just last for 2 weeks and you might get in trouble. Anyway, so you can see here that we request 1 GPU. You can change this if you want. You want to put nvidia.com/GPU number. Putting it in quotation marks, you don't need to my knowledge, but I put it there just because it might not work. No, it is. I don't think I have this file available because I don't want you running this unless you absolutely have to. And so to select a specific GPU, you want to use the affinity lines. So the affinity essentially allows you to choose specifically what you want. So once we go through all these things, we want to do the match expression, and we're looking at the specific GPU. So in this case, we want to use only GPUs in this list. So currently there's only one thing in this list, and we have the NVIDIA RTX A6000. If you want, we could add extra things like the 1080 Ti, but make sure that it does match whatever is here. So make sure it is case sensitive even as well. So if you do want to put a 1080 Ti, make sure you write exactly NVIDIA GeForce GTX 1080 Ti with all the dashes, and everything like that. And so that is how you can use Nautilus for your computation needs. Any last questions? I think that is the end of the presentation.
Does it wait to run until the specific GPU is available?
Yes, if you do request a A6000 and there are no A6000s, it will not run until it's able to find that or until it gives up. But yeah, thank you. If you have any questions, you can come up to me now. You'll probably want to play around with this on your own. If you do want access to Jupyter Hub and you don't want to deal with all this BS terminal command line things that, I'm gonna be honest, don't work half the time. Talk to me, send me a message on the Discord server, and I can get you access to the Jupyter Hub, which is essentially the same thing as Colab. Works well. You also have the terminal access there as well. But the same way that if you close your tab on Colab, you lose your progress. Same thing with Jupyter Hub. If you close the tab, you lose your progress. And yeah, that's it. Thank you. Yep. Any questions? We'll be up here for a little bit. How badly did I go? Oh, 7 minutes overboard. It's impressive.